The final countdown, a 2-week warning, a shadow glides through the blackness of space, a silent traveler on a collision course with Earth, about 100 meters across, roughly a football field, moving at tens of thousands of kilometers per hour. And we just found it. Our telescopes, our brilliant scientists, our global networks, all of them missed this one, until now. 14 days. A clock starts ticking for our global sense of security, a final exam we did not have time to study for. Not a dinosaur killer, but a city killer with the energy of many nuclear bombs. Hope is not lost, but we must get real. The work begins now. Eyes on the sky. How do we even know an asteroid is coming? The discovery begins with light. All over the world, and even in space, telescopes stand guard. Night after night, they image the heavens. Software compares images, hunting wandering points of light. Asteroids. Comets. A cosmic connect the dots. Global teams confirm, refine, and share the orbit. Models project years ahead to check close approaches to Earth. The Minor Planet Center catalogs discoveries and risks. But the sky is vast, resources finite, and the sun side is a dangerous blind spot. In 2013, Chelyabinsk arrived from the sun's direction. No warning. A city-sized problem, the threat of a 100-meter rock. Not a pebble, a solid mass, as wide as a city block, as tall as a 30-story tower. Hitting at over 60,000 kilometers per hour, it detonates on impact. Hundreds of megatons, beyond any human-made device. A crater more than a kilometer wide, hundreds of meters deep. Blast and thermal pulse flatten and ignite the urban core. Farther out, windows shatter and structures suffer. In the ocean, water rises as a traveling wall, racing across basins to distant coasts. Dust and soot dim sunlight for months, nudging global temperatures down. Food systems strain. One wrong impact can destroy a city and destabilize civilization for years. With 2 weeks, options narrow dramatically. The elegant nudge is the first casualty of a short timeline. Intercepts are precise, complex, and slow to mount. Plan, prepare, launch, cruise, rendezvous, all take time. Choices, deflection, disruption, or get people out of the way. Delivery is the bottleneck. In 2025, no rapid response interceptors exist. Typical asteroid missions take years, not days. Travel time alone can consume the window. We must weigh drastic options and prepare on the ground. Hard truth. An intercept from scratch in 14 days borders on impossible. The safest solution is a tiny velocity change, long before arrival. Smash a heavy spacecraft into the target. Debris jets add a push, a cosmic game of billiards. With months or years, a small nudge becomes a big miss. DART proved we can alter a small body's path. A Skokarbode Abind Sitorj historic milestone. But DART took years to plan and 10 months to cruise. At 2 weeks, the asteroid is deep in Earth's gravity. We'd need a colossal shove, but far beyond current rapid capabilities. An ultra-fast intercept in days is unprecedented and risky. The gentle push is our best long-lead tool, a solution for years, not days. When finesse fails, we consider brute force. Disruption, shatter it so fragments burn up. But asteroid interiors vary. Monolith or rubble pile, you might swap one bullet for a shotgun spread over a vast region. With 2 weeks, it's a blind roll of the dice. A nuclear standoff detonation could vaporize surface layers and push the rock. It provides a far bigger shove, perhaps enough on this timeline. But delivery systems don't exist for this purpose, and treaties and politics burn time. It could fracture the asteroid unpredictably, a last resort, powerful, but deeply flawed for a desperate situation. Faced with an unstoppable force, get out of the way, evacuate the predicted impact area and surrounding high-risk zones. If ocean impact, clear vulnerable coastlines, clear, calm, unified communication, backed by science, precise maps, routes, shelters, and what to bring. All channels, constant updates, mobilize buses, trains, military transport, and private vehicles, manage choke points to keep people moving, prioritize the vulnerable, practice plans, save lives, stock shelters at scale. This Kroikuboffen Eindurin in Kras, Boden Spine Dir de Bafthebrai. Is spreid vregen mai, Wajirin Nakrabratz, there's a necken pert the knee Wadrikerins, Brarikan juries on Bakandai. Though for my precurring get galab chaotic and difficult, but evacuation is proven and directly saves lives. In 2025 our detection is better than ever, and improving. Catalina, Pan-STARRS, The Rubin Observatory coming online. We're good at finding and predicting. We've demonstrated deflection physics, but no standing fleet, no ready rocket, no ready impactor, no nuclear intercept stock. Everything is bespoke, months to years for building, testing, launching. Emergency agencies, alerts and evacuation plans exist. But no nation drills for an asteroid of this scale and speed. Global response is politically thorny. We need protocols and a chain of command, now. Our tools are promising, but the shed isn't stocked or organized for sudden crisis. A 2-week warning is a wake-up call. And a roadmap. We need deliberate, global, multi-pronged preparation. Time is the most valuable resource in planetary defense. Invest in surveys, including space-based infrared to cover the sunside blind spot. Develop standardized interceptors and rapid launch playbooks. Practice the whole chain until it's routine. Compress years to months, then weeks. Strengthen civil defense. Better models, robust comms, real evacuation drills. Asteroid strikes are rare but real. Our job isn't fear, it's foresight. If we act now, tomorrow's warning won't be a countdown to disaster, but to a plan. Let's get to work.